Okay, your science book should be opened back up to page 373. Go to your chapter 8, lesson 2 notes. Put a squiggly line underneath number 2, I think. Or actually, no, it was underneath that diagram we did of the moon. No, underneath the word phases. Or was it? No, it was underneath the diagram we did of the moon. Yes, diagram. So put your squiggly line underneath the diagram we did of the moon phases, and then just write today's date because the chapter and the lesson is not changing, but the date is. And don't write number 3 yet because there may be a diagram I want you to draw before we get to number 3. Yes, or number 4. Yes. Don't put number 4 yet because there may be, I can't remember, but there may be a diagram that I want you to draw before we get to number 4. So just draw your squiggly line underneath our moon phases diagram and then write today's date. And you should be on page 373. Smith, you are going to begin with the moon's gravity. But wait just a second. Let's give everybody a chance. Yes, Carla? Page 373. So make sure you're on page 373. Okay, Smith, go ahead and start with the moon's gravity on page 373.
The moon's gravity. The moon has gravity. It pulls slightly on Earth. On the side of Earth that faces the moon, the water or land bulges slightly outward. The moon pulls more than the sun because it is closer to Earth.
So, the moon has gravity. Because the moon has gravity, it's actually pulling slightly on Earth. Earth is also pulling on the moon, which is why the moon stays around the Earth. But while the Earth is pulling on the moon strongly enough to keep it in our orbit, the moon is also slightly pulling on Earth. That just means that the water, like in the oceans and stuff, in large bodies of water like oceans, it gets slightly bigger. It bulges a little bit, which leads to the next paragraph that Smith is going to also read.
Earth's tides. The moon's gravity causes tides. Tides are the daily rise and fall of the ocean surface.
Let's add that word. So yes, we'll go ahead and put number 4, which is the word tides. And what are tides, Smith?
The daily rise and fall of the ocean's surface.
The daily rise and fall of the ocean's surface. So think, if you've ever been to the beach before, especially like the Atlantic coast, like the big ocean coast rather than the Gulf, but if you've been to the Gulf, you see this too. Sometimes the water is closer to like where you're, like to the end of the beach, like it's further up the beach sometimes, and then sometimes it's further out. And usually it's the same, like in the morning, it'll be really close. Like when you first get there early in the morning, the water's like really close and really far up the beach. But then later in the afternoon, it's really far down the beach. You have a lot more space, a lot more sand. That's the tide, which is caused by the moon. The moon pulling on that water is what causes. Remember, it says the water bulges a little bit. That's what causes this. That's what causes the high tide, I think. Smith, finish out that paragraph.
Most places on Earth have high tides and low tides.
So high tides is when the, the high tide is when the Earth is not. Wait, I'm sorry. high tide is when the moon's gravity is not pulling on the water. Because think about it, when it bulges, it makes the middle kind of go out, which pulls the edges in. Think if you have, let me grab a tissue. Colin, let me have a tissue. So right now, the edges are all the way out. But now imagine I pull here. I wish I had, let's see. No, I need something dark so that you can see. Let me have your sketch pad. Quick. So that you can see the edges. So, here's this tissue. I'm not pulling on it. There's no gravity pulling on it right now. See where the edges are. Okay? But now I'm going to pull on it in the middle. The edges move in. Do you see that? It's the same with the moon. When the moon is facing the earth, this is the ocean, it bulges. And the tides get lower. But when the moon is not facing the earth, it's pulling on the other side. These are staying further out, high tide. The water's further up the shore because nothing's pulling on it in the middle, pulling the tides way out to low tide. Okay? So does everybody kind of understand the high tide and low tide? The moon is pulling it out, it's bulging, so it's low tide. The water is further out. Here, the moon's on the other side, and the water, it's high tide. Okay. Just put this in here so put it back. Okay. Go ahead and turn the page, and now we're going to talk about eclipses. And we should be able to do, if we have time, we should be able to do a little demonstration. I had Zadie bring her flashlight back. And if we have time, we'll do a little demonstration. Okay. This diagram should look familiar. So, make sure you're listening closely. Lena, please read.
What is an eclipse? An eclipse.
Oh, a little slower.
What is an eclipse? An eclipse is a shadow cast by the earth or the moon.
Let's add that word. Number 5 is the word eclipse. And Lena, what is an eclipse?
An eclipse is a shadow cast by the earth or moon.
A shadow cast by the earth or the moon. So the eclipse is a shadow cast by the earth or the moon. We've seen one here. Lena, you even saw one here. Because it was when you guys were in first grade. Remember, we went out there and you had to wear, well, I don't know, guys might have gone somewhere different. We went out there, but we had the glasses and you got to look up. Yes, Smith.
I was at the Pink Palace when that happened. I was there.
Yes.
Why do you have to wear special glasses?
Because you have to look at the sun. And is it smart to look at the sun? No. No, not at all. It can literally burn your eyes. Okay, and we'll actually read about that on this page. Hands down. Lena, keep reading.
The diagram shows the two basic kinds.
So, let's look at the diagram. We're not going to go in depth about it yet because we want to read about it first. But the picture on the top is a lunar eclipse. Notice that the earth is between the sun and the moon, and the earth is casting a shadow on the moon. Can any light shine on the moon right here in this situation, in the top diagram? So would we be able to see the moon at all in this case? No. The earth is completely blocking the light. And does the moon create its own light, class? No. It's not like the sun where it shines no matter what. The only reason we can see it is because the sunlight is shining on it. But here, the earth is blocking it completely. There is no sunlight shining on it, so we can't see it at all. Then on the bottom, we have a solar eclipse, which is where the moon is between the sun and the earth. Look at how the moon is casting just a small shadow. So where that shadow is, will we be able to see the whole sun? Wherever that shadow is landing, will we be able to see the whole sun? No. What's in the way?
Shadow.
But what's in the way? What's causing the shadow?
Oh, the moon.
The moon. That's what we saw, what was it, like 3.5 years ago. We saw a solar eclipse. Remember, it got a little bit darker. And when you looked, you could when you looked through the glasses, you could only see like a little part of the sun. That's because the moon was in the way. It was blocking part of the sun. Now, let's go a little bit more in depth. Lena, tell us about lunar eclipses.
Lunar eclipse. In a lunar eclipse, Earth casts a shadow on the moon.
Okay? What's number 6?
Lunar eclipse.
Lunar eclipse. And what happens in a lunar eclipse, Lena?
Earth casts a shadow on the moon.
Earth casts a shadow on the moon. Okay?
This happens when the Earth is directly between the sun and the moon. The moon passes through Earth's shadow.
Good. So usually, the moon is kind of like up, like in the diagram on page 370. Look back at the diagram on page 370. You can see that the moon is kind of above the Earth. So we're able to see the light from the moon, but the sun is still shining on it. But then look at the difference on the lunar eclipse on page 374. The Earth is directly in front of the moon. That's why eclipses don't happen all the time. It just depends on that revolution and all of that of the moon. Yes? Yes, always. Mm-hmm. So usually, the moon is like above the Earth, like on page 370. So everybody quickly look at page 370 so that you can see where the moon normally is. It's usually to where it's not directly behind or in front of the Earth. It's kind of up a little. But occasionally, because of our orbits and our rotations and everything, the moon is not above the Earth. It's directly behind the Earth. So no light can shine onto the moon in these cases. Zadie, go grab your flashlight and be the sun. I will be Earth. And Carla, come be the moon. I need somebody small. Because the moon is smaller than the Earth. So I need to make sure that they are smaller than me. Yes. Yes, go ahead and turn off the lights. Okay, so we're going to, so you go behind me. Shh. We are well, wait.
Do you want me to do the camera?
No, it's okay. So, Carla is the moon. I am the Earth. Zadie is the sun. So right now, there is a lunar eclipse. You can see that you can't see Carla. There's no light on Carla. Ignore this little bit of light on her sleeve. Look at her face. There is no light on Carla because me, the Earth, is completely blocking her. Does everybody see that? So right now there's a lunar eclipse, but usually the sun and the moon is, the Earth and the moon is like this. So you can still see her face, and you can see the light on mine. So right now, these people back here in Russia, it's nighttime because they can see the light of the moon. And here in North America, it's daytime because the sun is on my face. This is how it normally is, but during a lunar eclipse, it's more the moon moves, but the moon moves or is in a different spot so that Earth is blocking it. We can't see any light. I'll need you in a minute. Go back to your seat. I'll need you again in a minute.
Okay.
So that was a lunar eclipse. The Earth is completely blocking the moon So even though maybe we're supposed to be seeing a full moon, we can't see anything because the moon is completely in the Earth's shadow. Aaron, read to us about solar eclipses. This is what we saw 3.5 years ago.
Solar eclipse.
A little louder.
In a solar eclipse, the moon casts a shadow on Earth.
So, what's our next word, Aaron?
Solar eclipse.
Solar eclipse. And what happens during a solar eclipse?
The moon casts a shadow on Earth.
Good. The moon casts a shadow on Earth. Notice how these two definitions are pretty much exactly the same. We just flip-flop Earth and the moon. Carla, did you write those? Okay. Notice how they're exactly the same. We just flip-flop the Earth and the moon. So in a lunar eclipse, Earth casts a shadow. Whoops. In a lunar eclipse, Earth casts a shadow on the moon, like what we just showed you with Carla and I and like the top diagram. In a solar eclipse, the moon casts a shadow on Earth, like you see in the bottom diagram, and as soon as Aaron's finished, we'll demonstrate again. So Aaron, continue.
Solar eclipses happen only.
A little louder.
Solar eclipses happen only during the new moon.
Pause. Because what phase of the moon is it when the moon is between Earth and the sun? Can we see the lighted side of the moon when the moon is between Earth and the sun? No, because the lighted side's on the other side. So it can only, a solar eclipse can only happen during a new moon. Otherwise, the moon isn't in the right place. The moon has to be between Earth and sun. Okay, keep going.
A partial solar eclipse is when part of the sun is blocked.
So look at that word partial. What's the base word of partial? Colin. Part. So a partial solar eclipse is when part of the sun is blocked. By what? What is the sun blocked by in a partial solar eclipse? Carla?
The sun.
What is the sun blocked by in a partial solar eclipse?
The moon.
The moon. Okay, keep going.
A total solar eclipse blocks all of the sun.
A total solar eclipse blocks all of the sun. Total means all of it. So total solar eclipse blocks all of the sun. The one we saw from where we were in Memphis, Tennessee, we saw a partial solar eclipse. Because did it get completely dark? Was the sun ever completely blocked where we were? No, but it was like the most blocked it's been in a really long time. And if you went just like an hour north, you got to see a total solar eclipse. Because there, they were in a position on Earth where the whole sun was blocked in that one. It was like where the point, look at this little cone behind the moon. Cone is like a triangle with a round bottom, remember? Look at this little point. Right where it's pointing to on the Earth, on this bottom diagram, they're going to have a total solar eclipse. Everywhere else around is going to have partial because the shadow's only partially touching them, not entirely. Okay, so now let's demonstrate a solar eclipse. So, Zadie and Carla, come back. Carla is still the moon. I am still the Earth. Zadie is still the sun. Okay? But now, so this is what it normally looks like. Okay, yeah. See? Here's the lighted side of the moon. Here, come back a little bit. Come a little closer. A little closer. There you go. Here's the lighted side of the moon. Here's me. I can't see any light because it's a new moon. But I'm still getting sunlight, right? But during a solar eclipse, we're like even. And now, do you see the front of my face is not getting any light because the moon is blocking me. So does everybody see that? Here's regular. I can still see light, but I can't see the lighted side of the moon. But during a solar eclipse, the moon is in the way. It's blocking the light from getting to Earth. Okay? Thank you.
And Miss Wild Bell's flying me a little bit.
It's a very bright. It works really well for the sun. Okay, so does everybody understand eclipses? What is a lunar eclipse? What is casting the shadow? What is causing the shadow in a lunar eclipse? Cullen.
Earth.
Earth. It is putting a shadow on what? In a lunar eclipse, Earth is casting a shadow on what? Zadie.
The moon.
The moon. In a solar eclipse, what is causing the shadow? Ethan? In a solar eclipse, what is causing the shadow? The moon. The moon is putting a shadow on what? Michaela?
Earth.
Earth. So see, they're opposite. In a lunar eclipse, Earth casts a shadow on the moon. In a solar eclipse, the moon casts a shadow on Earth. In this diagram, let's look. Lunar eclipse, where is the moon? Carla, off your head, please. Lunar eclipse, where is the moon? Smith.
Behind Earth.
Behind Earth. The Earth is in the way. Can't see any light on the moon, even though we should, because Earth is in the way. In a solar eclipse, where is the moon? Aaron.
In front.
So between
The sun.
the moon. So it's blocking some of the light from getting to Earth. Normally it's not, because the moon is above the Earth, like we see on page 370. So imagine the moon was between the sun and the Earth. If it was above, it wouldn't cast a shadow on us, right? The shadow would be behind, like off into space. But because during eclipses, the moon's orbit and our orbit kind of works out to where it's right in front of us, then we have an eclipse. That's why we don't have eclipses all the time. Because our orbit and the moon's orbit have to be in a certain spot for the moon to be right in front of us. Normally it's up above, like on page 370. Quickly, Cullen, then Ethan, then we're going to move on.
Do you know when eclipses are coming?
Yes, they can predict them because they know our orbits. Do our orbits really ever change? No, so they can predict them, but it's usually a while between. Now the solar and partial, that's a little harder to determine because they have to figure out exactly where the moon is to figure out who is going to have a total solar eclipse and what areas are going to have a partial solar eclipse. Ethan, quickly, and then we're going to move on.
Does other planets have moons?
Yes, most other planets have moons. Not all of them, but most of them do.
Are they
Jupiter, I think, has like 28. Or I might be thinking of Saturn has like 24.
Are they
Maybe. I don't know. That's just how it is. Okay. Read next. Me. Follow along with your finger. Eclipse safety. Only a lunar eclipse is safe to observe. Why is it safe to look at a lunar eclipse? Zari?
Because the sun is not in your eyes and the moonlight is not also in your eyes.
The sun isn't in your eyes during a lunar eclipse. Also, does it burn your eyes to look at the moon? No, because is the moon putting off its own light? No. Where is the light that we see on the moon coming from? Zadie?
The sun.
The sun, and it's really, really, really far away, so it doesn't hurt your eyes to look at a lunar eclipse. Also, the sun is behind you, and when there's a lunar eclipse, do you even see all the moon? No. So even that little bit of brightness that you usually see even with the full moon, there's even less. Keep going, me. Looking at a solar eclipse will damage your eyes or cause blindness. Sunglasses do not help. That's why even in sunglasses, you do not look at the sun. It's too bright. It can even burn your eyes wearing sunglasses. For this reason, you should never look directly at the sun during an eclipse. Scientists use special tools to observe solar eclipses safely, or we can use those glasses like they gave us before. So let's answer this compare and contrast question at the bottom. How is a lunar eclipse like a solar eclipse? So somebody compare a lunar eclipse to a solar eclipse. Lena, how are they alike? Compare them.
They're both eclipses.
Okay, what does that mean?
That they one of them has.
Well, tell me how they're alike. So it can't be one of them does this, one of them does that, because that'll be differences.
They're alike because they both have. They're both eclipses and they both cast a shadow.
So they both cast shadows. In both of them, there is a shadow being cast. So that leads to the other part. How are they different? Contrast a lunar and solar eclipse. They're alike, that you can compare them by saying they both cast shadows. Something is casting a shadow. But now we're contrasting them. How are they different? Zadie.
They're different because in the solar eclipse, the moon is in front.
So what's happening in a solar eclipse? If the moon is in front, that means what's happening?
The moon is casting a shadow on Earth.
So in a solar eclipse, the moon is casting a shadow on Earth. How is that different from a lunar eclipse?
In the lunar eclipse, Earth is casting a shadow on the moon.
Good. In a lunar eclipse, Earth is casting a shadow on the moon because where is the moon? Or where's the Earth? In a lunar eclipse, where's the Earth?
The Earth is in front of
So think about it. You said that the moon casts a shadow on Earth in a solar eclipse because the moon is between the sun and the Earth. So the Earth casts a shadow on the moon in a lunar eclipse because the Earth is
between the sun and the moon.
between the sun and the moon. Very good. Okay, we already answered the question, why is it safe to observe a lunar eclipse? Because sunlight damages our eyes. Does moonlight damage our eyes? No, the light's not even coming from the moon. We're just seeing it, the light caused by the sun. Very good. Okay, now we have plenty of time to do the rest of your independent practice. So the morning work was the first part. Now the back, what are eclipses, is the next part. Any questions about eclipses before I pass back your science breakfast for your brain? Zari, you'll just get it out from wherever it was. You can just go ahead and do the other side and send me both of them tonight or tomorrow morning. Zadie, we'll just go across. Zadie, Smith, Zari, Kingston, and then we're gonna move on.
And have you ever looked at the sun? It for a little bit, it almost feels like your eyes start to water.
Mm-hmm. And then sometimes you see like a blank spot for a little bit. Yep, so that should tell you right away, don't look at that because it's doing something bad to my eyes. Smith?
Can we put our both notebooks away?
Yes. Was that your question? Okay. Zari, what's your question?
My question was, are we after we finish the independent practice, what would you like us to do?
Finish grammar independent practice from yesterday or read? Victoria, what was your question? Now, I'm asking for questions about eclipses, so if you have other questions, you can ask me privately later. Is it a question about an eclipse? Okay, Kingston, was your question about an eclipse? Okay. Any other questions about eclipses? Aaron and Carla, then we'll move on. Aaron?
We didn't get to go outside to see the eclipse when we were in first grade, but we watched it on the news.
Oh, did you? Oh.
I think we were on
Maybe it also might have been because I don't know if they were letting kids below 3rd grade or 2nd grade.
I thought to see it because my mom took me out of the
Yeah.
library.
If your parents came, I think if you were younger, if you were 2nd grade or below, your parents had to come and get you.
Well,
Otherwise,
Also, she didn't want Haley to be out there by herself.
Yeah. Carla, what was your question?
And then my question is, when we get the sheet back, will the question will be about the eclipse?
About the diagram on page 374. Yes, when you get your sheet back, it will be about the diagram on page 374. So look at the diagram and around the diagram to help you answer the questions. Yes, quickly.
In first grade, I got to see the solar eclipse because my dad took me out for lunch.
Yes. So some people did get to see it. But I think only third and fourth grade and up, like third grade and up, were actually allowed, like the teachers were allowed to take them outside. I think everybody else, they were like, a parent has to choose that. Okay,